Hello again. My name is Jorge Romeu, and I'm trying to share my contents. Hopefully it will come out now. Yes. This paper on applying principal components is part of a larger effort that we have been undertaking for the past few months as a retired academician and researcher. I have been developing short and straightforward papers and distributing them around some institutions and researchers like State University of New York in upstate, in Syracuse, the Masonic Medical Research Institute, NIH, and so on. And we are going to present the principal components. But we also have a paper dealing with survival analysis using covariates. We have a Markov model to study college reopening. We have a model about racial impacts of minorities and so forth. You can find all those URLs in the paper or in our webpage, which is in the bottom of this screen here. The current multivariate analysis paper has the following objectives: to explore the impact of county and regional data in New York State with respect to opening of the regions, because this paper was done at the time that New York State was in lockdown. We also want to find out, among the several metrics that have been collected, which ones are better to allow to separate these regions or these counties into those that can open and those that should remain closed for a few more weeks. Through that, we obtain the discriminant analysis equation that is able to classify all New York states according to their chances of becoming reopened with respect with their infection rates and so forth, and also to determine which of the metrics are going to be more useful. Principal components, and this is a paper that is done for the medical and healthcare and areas and researchers who are not specifically very cognizant of statistics, so we work like a tutorial. So we explain that principal components are implemented to explore the impact and to reduce the number of variables from a large number to a smaller subset that we can use. And then the discriminant analysis is used to assess which one of these variables are really impacting. One of the things that are obtained from statistical analysis is that some variables that we collect are not very useful, and other variables that we need are not being collected. When we start doing analysis, we can show the public health community that this data should be collected. Some of the separating variables could be high versus low infection, regions improving or worsening, regions that are densely populated or sparsely populated, and then therefore are safe to reopen or not, and so forth. We have taken this data. This data was from the month of May in New York State. So it was at the very beginning, and it was taken from the dashboard of New York State. And they had, for the regions, all the regions in New York State, we have new hospitalizations, deaths, hospitalizations per county and regional residents. The share percent of beds that are due to COVID-19, and the same for the ICUs. A percent of the residents of the state tested by 1,000 residents, and the status. The status is whether the New York State had determined that they were ready or not ready to open according to their infection rates. There are some problems with variables which are not able to be used across the board, like number of beds and like number of infections. Some people have said, for example, the United States have a larger number of deaths and a larger number of infections than any industrialized nation in Europe. And that's natural because the United States is a country of 330 million, and the largest industrialized nation in Europe is Germany that has 100 million. So you have to standardize your variables. That's why we deal with percent positives per 10,000 inhabitants of the county or the region, percent deaths per 10,000, and so on and so on. And then we do not have data about the density, and we are going to instead use rural and urban according to what the predominant status is. These are three New York State metrics that we use: the positives of the testing, the deaths, and the density standardized by 10,000 inhabitants. We performed a principal components analysis. You could also do a factor analysis, and this could lead to similar results. And we concentrated, we had so many variables, we concentrated into two variables: component number one, component number two. Component number one explained 96% of the problem, so you can even just leave it there. Component number two, approximately 4% of the problem. This is useful, so you can plot it and try to find out, which is what the principal component was very helpful with, not only which variables are the strongest, but how you can cluster the regions and then try to find out what are the common characteristics. I always stress to the public health professionals that statistics is a science that flags problems. So you flag the region, and then it becomes a problem of the subject matter expert to find out what the characteristics are. But statistics is very useful because you don't waste your time going all over the place. You can go directly to where statistics is flagging you that the problem is. These are your variable principal component loadings. And with those, what I did here was to do a score plot, and you can find in the left of this graphic this cluster of points, and this cluster of points represents the mostly upstate New York counties, which are less densely populated and have a much lower infection level. From one of the previous papers, we heard correctly that the density of the population is a factor, as well as poverty is a factor. One of our papers was about the link between poverty and racial impact. And actually what happens is that most of the poor or the African American are overwhelmingly represented among the poor, and the situation that we found was that it was the characteristics shared by the poor, which explains why those African Americans from the upper classes among African Americans, and you can find them in government, you can find them in sports, are less prone to become infected. Now, we have a score corresponding to the counties, and corresponding to urban and rural. And in our paper, you will find that they are given in different colors, so you can read them there. The paper is in the website here of the conference, and you can find out that the counties and regions corresponding to New York City, which have a very large number of positives and deaths, have very high scores to the right, and lower regions like Allegheny, who have a very low number of positives and deaths per 10,000 inhabitants, have a totally different situation in the graph.
5 minutes left.
5 minutes? Okay.
Yep.
So everything is in the paper. There are some analyses, like discriminant analysis, where you could actually separate the regions between those who were going to open and those who were not safe to open yet. We calculated the Halanovich distance, because you can calculate more than one distance with different variables and choose the best there. And finally, you have the conclusions. This is a graph of the separation through the Fisher discriminant functions. And the conclusions is that principal component is a nice way to start. So you can summarize your variables, or you can select which ones are the better, and discriminant functions allow you to separate your regions, your counties, between those that are safe to open and those that should wait a little bit longer. Thank you very much. If you have any questions, I'll be happy to field them.